Welcome to the quick revision session on the structure of atoms. This is the first lesson in a little bunch of lessons where if you do not really understand the structure of atoms, a lot of radioactivity you're not going to be too happy with. So it's important that we get this straight from the start. Three quick things to do. We're going to know the properties of protons, neutrons and electrons. We've got to understand the structure of the atom and how we represent it in terms of its atomic representation to make life a bit easier when we write them down. And also we've got to know what this word isotope means. The diagram of the atom we know from GCSE looks like this. If we look at the nucleus in the centre, we've got two types of particles in there, if you like, and around the outside we've got the third type of particle. If we take a look first of all at the electrons are on the outside of the atom. We say, you might know from your chemistry, that they go in shells, but in terms of your physics, all you need to know is that the electrons are on the outside. But most of nuclear physics is all to do with what's in the nucleus, and in the nucleus are the protons, which in this diagram are labelled red, and the neutrons, which in this diagram are labelled blue. Now, a little note of caution, the colours are totally meaningless. Sometimes you will see diagrams where the protons are black or the protons are white and the neutrons are the other way around. You just need to be very careful that you read the labels or have a look at any other clues on the diagram. But for what we're looking at today, the protons are red and the neutrons are blue. So I mean, in summary, this little sentence at the bottom, an atom has a tiny nucleus. This is at the centre and it contains all of the protons and all of the neutrons. And key, just for the rest of this session, the number of protons tells you which element it is. So if you want to know what type of element this atom is, you need to count the protons, and we have got 4 protons. Okay, the little summary then you've got at the top of the page still. The other little bit of information you need to know for GCSE is how massive these particles are and what type of charge they have. Now, the proton and the neutron are very similar, so we say that relative to each other, their relative mass is 1. This doesn't mean it's 1 kilogram or 1 gram, obviously, but it does mean that they are same or similar masses. So relative to each other, they are the same. Now, the electron is very, very small. Relative to the others, it's very, very small. In terms of the charge, proton, most people are fairly happy that the protons are positive. The neutrons are neutral and the electrons are negative. So important, you need to know pretty much all of that information on the table. If we come back to representing our atom, if you think about our diagram at the start, we had 4 protons, 4 neutrons and 4 electrons. That was the element beryllium. Now, rather than drawing it out like you saw at the start, we tend to write it like this. You write the symbol, if you like. Now, the symbol for beryllium is Be. You won't have to know these, you'll be given them in the exam, but you need to know that we don't draw it out longhand like the diagram we saw at the start, which looks like planets in a solar system. We draw it like this. Now, the bottom number is the number of protons. So for beryllium it was 4 protons. The top number is the mass number, and the mass number is the number of protons and neutrons together. So if you're given both of these numbers, you can work out the number of neutrons. The number of neutrons would be the mass minus the atomic, or the number of protons and neutrons minus the number of protons would give you the number of neutrons, which for our case was beryllium. And as we said, the Be is the symbol for beryllium. So you need to be happy to interpret, is probably the best word. When you see symbols with atomic numbers and mass numbers, you need to be able to interpret these. Okay, the word isotope is important. If we have a look at all of these that are appearing on screen, they are all isotopes of beryllium. How do I know? Well, they've all got 4 protons. If you look at the bottom numbers, the bottom number are all 4. So these are definitely all beryllium, but if you look at the top numbers, there is a difference between these nuclei of beryllium, and that difference is in the number of neutrons. This has got 7 minus 4, this has got 3 neutrons, 8 minus 4 will give you 4 neutrons, 9 minus 4 will give you 5 neutrons, 10 minus 4 will give you 6 neutrons. Now these are still all beryllium. No one of these is a better beryllium than the other. They are all beryllium. They are all chemically the same, but they have different numbers of neutrons, and we call these isotopes. This word isotope does cause some confusion. Think of it as maybe version or something like that, but they are all called isotopes of beryllium. And the thing to remember is that isotopes have the same number of protons but different numbers of neutrons. Okay, in summary then, just to make sure you've got all this, how would we write these nuclei? I've got some pictures of nuclei. So here you can see I'm sticking with red, meaning protons. So I can see here that this is a red 1 proton and we have 1 neutron. So if I count them up, the protons are 1. If I had my periodic table, I know that this must be hydrogen with 1 proton. It's got a mass number of 2, so if I wrote this out, remember the mass number is the number of these added together. If I wrote this out, it'd look like that. H for hydrogen, atomic number of 1, mass number of 2. Okay, let's have a look at this one. Second one, we've got 2 protons, but we've got protons and neutrons are 4, so protons are 2. If I look at my periodic table, I know that that must be helium. The mass number is 4, so if I wrote this out, again I'd have the symbol for helium, the atomic number of 2, and the mass number is 4. Same again for this one. I've got 3 protons and 4 neutrons. Now I know from my periodic table that 3 protons must be lithium. The mass number, if I add all these lot together, it's got to be 7. So on my periodic table, if I found the symbol for lithium, it's Li, and my bottom number would be 3 for the atomic number, 3 protons, and my top number would be 7. And finally, the hardest, I suppose, but it's all the same idea. We've got 1, 2, 3, 4, 5, 6 protons. 6 protons must mean it's carbon, and then we have 1, 2, 3, 4, 5, 6 neutrons. So we've got something with a 6 at the bottom and a 12 at the top, and it's definitely carbon. Symbol for carbon is C, so we have carbon 6 with 6 at the bottom, sorry, and 12 at the top.